Solving for number 5. This is a quadratic, so the way we solve this is still going to be the same with the two cases, but we're going to have a quadratic question. So in case 1, you're going to set your equation positive. So x squared minus 2x minus 1 equals 0. And we're going to solve for that now. Now, if you tried to factor this one, you're never going to, the only factors of -1 are +1 and -1, and that does not, of course, add to -2. So you're going to have to use the quadratic formula here. So x is equal to -2 plus or minus the square root of -2 squared minus 4 times 1 times -1 over 2 times 1. So x is equal to 2 plus or minus 4 plus 4 over 2. So x is equal to 2 plus or minus square root of 8 over 2. X is equal to 2 plus or minus, when you simplify root 8, you would get square root of 4 times 2. So that's 2 root 2 over 2. 2, 2, and 2 all is reduced down. So you get x is equal to plus or minus root 2. Let's solve for case 2. You're going to bring the negative sign through the brackets now. So you're going to get negative x squared minus 2x, plus 2x now. So you're going to get negative x squared plus 2x equals 1. So let's solve for this one. I'm going to move things this way, so I have positive x. So I have 0 equals x squared minus 2x plus 1. And this one factors. So we're going to have x minus 1, x minus 1. So two numbers are multiplied to -1 and add to -2. X equals 1, x equals 1. We don't need to write that twice. Now we have 3 answers. Plus or minus 2 is 2 answers. And 1. Let's check. I have a little bit more room to check this one here, so I'm going to start with this one actually. So let's check x equals 1 in our original equation. So we'll plug in 1 squared minus 2 times 1 equals 1. 1 minus 2 equals 1. -1 equals 1. 1 equals 1. So this is a solution. Okay, now we need to check the other one. I'm going to go over here where I have a little bit more space. I'm going to check when x equals 1 plus root 2. So I'm going to check that here. So we're going to plug this in for x. So 1 plus root 2 squared minus 2 times 1 plus root 2 equals 1. So I'm going to show you how to do this with the radicals. With this radical, this isn't a huge radical. If this gets more complicated and you had kept this as a division, if it was a calculator question, you could convert this to a decimal and plug it in with your calculator. So in some questions, that would be allowed just to save us the time on checking. But I want to still make sure you can algebraically check with the radical, and it reviews our radical skills as well. So here we need to FOIL this out. 1 plus root 2 times 1 plus root 2 minus 2 minus 2 root 2 equals 1. Let's FOIL this out. So you get 1 outside and inside, so you get plus root 2 plus root 2. Last, you're going to get plus 2 minus 2 root 2 equals 1. So combining like terms, you get 1 plus 2, so 3 minus 2, so you're going to get 1, and you're going to get root 2 plus root 2 is 2 root 2 minus root 2, so those actually all cancel out. So you get the absolute value of 1 equals 1, so 1 equals 1. So that means this is one of the solutions. Let's check x equals 1 minus root 2. I have a little more room here, so I'm just going to space this out a little better for us. 1 minus root 2 squared minus 2 times 1 minus root 2 equals 1. So I plug this in for x in the equation. We're going to need to FOIL this again. It's going to look very similar to the other check we just did. Bring through the -2 equals 1. Foiling this out, 1 times 1. I'm going to combine my like terms, I think, on this one as I go. So I get negative root 2, so I'm actually going to get -2 root 2 plus root 2 times root 2 is 2 minus 2 plus root 2 equals 1. Oops, this should be 2 root 2. Sorry, I didn't notice that till just now. Thought maybe I forgot I combined something. I've multiplied this through. This is 2 root 2, so this is 2 root 2. Let's look at combining like terms. These cancel, so we get 1 plus 2, 3 minus 2, so we get 1 equals 1 again. So 1 equals 1 is true. So this is also a solution. So you can even circle it here if you want. I've got it here, but as long as you clearly show that all of those are solutions.